Hi, this is Tom Loschiavo, Chemistry Education Manager at Pasco Scientific, and I'm here to talk about the atmospheric property chamber as it can be used in a chemistry context. So the atmospheric property chamber is a great way to study gases. I can use a syringe to change the volume of the gas or add different samples of gas. I can attach it to a chemistry sensor where I can measure the pressure and temperature. It also has additional ports where I can attach additional probes like pH, conductivity, and oxidation reduction potential. So first we're going to look at this as a way to study gas properties. So I'm going to go over to Spark, and I'm going to use a new feature in Spark. So I'm going to build a page, and I'm going to look at pressure, temperature on a multiple y-axis. So I'm going to look at those two things versus time. So I'm going to click the multiple y. I'm going to hit OK. And now I have pressure and temperature on the y-axis and time on the x-axis. So I'm going to hit Start to get a baseline and understand what's going on. So right now my y1, which is my pressure, is around 100 kilopascals. My y2, which is my temperature in Celsius, is around 20 degrees Celsius, which is what I expect. So I'm going to look at these things as they change while I vary the volume of gas in here. So right now I have a syringe attached to a stopcock, and I have it open. So I'm just going to I'm going to push on the syringe to decrease the volume. And we're going to scale this. So now I can see that as I pushed on the syringe, both the pressure and the temperature increased because they are related. And I can do the same by pulling out the syringe. And again, we'll auto-scale this. Make sure that's good. And again, we can see that those two things dipped simultaneously because they are related. The temperature is going to re-equilibrate to the room conditions after a while. But this is a nice way to study one gas property. The other thing I can do with this, which the stopcock allows me to do, is I can look at adding samples of gas. So I'm going to look at a new page. We'll stop that collection. I'm just going to look at pressure this time, and I'm going to add volumes or moles of gas. So I'm going to look at pressure and look at that on a graph again. And I'm going to hide the first run. I'm just going to worry about this next run. So what this allows me to do is this allows me to add a sample of gas and then reseal the container. Now if you think the pressures are going to get too high, you can change the direction of the stoppers in here so that they're facing outward. So I'm going to take a 30 milliliter sample of gas and attach it while this is closed. And I'm going to hit play. And there's my initial pressure. I'm going to open this up, inject my sample, close it up again. Now I can see that the pressure changed proportional to that amount of gas that I added. And I can check that relationship by adding another 30 milliliters. So again, sealed. I'm going to put that back on. I'm going to open it up again. And I'm going to inject. And I can seal it up again. So I can add or remove particular amounts of gases and see how that changes the pressure. So this is a great way to study gas properties, but I also want to be able to study gas reactions. And to do that, I'm going to set up some additional equipment. OK, so we've set up the atmospheric property chamber as a reaction vessel. So let me explain what I did. I opened up the atmospheric property chamber using the thumb screws. I put a beaker in with some water and some indicator. I inserted a pH meter. On the end of the pH meter, I have a micro stir bar, and that's all over a stir plate. And this way, my solution is constantly mixing. So what I'm going to do is I'm going to inject gases and see how those gases affect the solution. I'm not injecting the gases directly into the solution, but over the solution, and we can observe atmospheric properties in that way. So first, I'm going to set up my Spark view. And I'm going to build a graph using, again, using the multiple y-axis. This time I'm going to look at pressure and pH as a function of time. And again, I'm going to get a baseline just to see what's going on. So I'm going to hit play. And I have my y1, which is my pressure, around 100 kilopascals. and my Y2, which is my pH, which is around 8.5 units. So first I'm going to inject some air. So again, I'm going to take my syringe, and I'm going to take 50 milliliters of air, attach it, inject, and then close it up. So if we zoom in on this a little bit, we can see that the pressure changed, but the pH is remaining the same. That's because the air that I'm injecting isn't really doing anything with the water. But now I can go a step further and inject gases and see how those gases affect the water. So I'm going to stop my sample, stop my first run. I'm going to open up the stopcock to release the pressure, so I'm starting at the same point. And this time I'm going to inject some CO2. So I'm just going to get a baseline again. And we'll auto-scale that. And again, looks like it's the same points, which is great. So now I need to collect some CO2 so I can inject some CO2. I'm going to close this. And to generate and collect CO2, I'm just going to add an acid to a carbonate or a bicarbonate. I'm going to pour some acid in. And I'm going to suck up some of that CO2. I'm not sucking up any of the liquid, just the gas. Again, we'll go about 50 milliliters. I'm going to attach it. Now, I didn't inject yet, so I'm still at that same baseline. Now I'm going to open this up, inject the CO2, close it. And now we can see from the display that the pressure change is exactly the same. I did another 50 milliliters. It looks like that same pressure change occurred. The pH so far is staying about the same, but we'll see what happens as the reaction proceeds. Now, this reaction is fairly slow. What happens is the CO2 in the atmosphere has to equilibrate into the solution. I'm not injecting it directly, so it does take a little bit of time. But we'll notice even now that the pressure is starting to drop. The pH is starting to drop as the pressure remains the same, and it's actually dropping pretty dramatically. And we'll let this reaction go for a minute as this CO2 gas equilibrates into the water. Okay, so after about 2.5 to 3 minutes of the reaction happening, you notice the indicator is starting to change color. It went from that blue-green to now a green-yellow. And you also definitely notice that the pH dropped fairly dramatically from 8.6 down to currently 7.6. So the atmospheric property chamber allows us to do this. It allows us to interact or to react gases and to study those gas properties in a closed system. This has been Tom Loschiavo at Pasco Scientific. Feel free to reach me at chemistry@pasco.com. Thank you.